All right, so let's continue with the next section here. This is 2.5, finding derivatives using chain rule. The objectives are to find the derivative of a function using the chain rule, to be able to find the derivative of a function using the general power rule, which comes from a combination of the chain rule with the power rule, and then review the basic differential rules of algebraic functions. So in this section, we're adding two more rules to our derivative rule table. The chain and the general power rule allow us to find the derivative of functions that are composite functions. In particular, the general power rule will help us find the derivative of a composite function where the outer function is in power form. So let's review real quick composite function versus not composite function. This is something from algebra. So in this section, we're gonna review those that definition, and then we'll begin defining how the chain rule gonna help us. All right. So the chain rule will let us find the derivative of a composition function. An informal way to think about composition function is to think about a function inside another function. So that is, so we have here a comparison of the same function here. If you notice, not a composition function, so chain rule is not needed here. So here you just have a basic polynomial, another basic polynomial. Here you have a quotient of a polynomial. So what is the difference between this and how this going to be a composition of a function? Well, as soon as that is inside another function. Here the outside function is the cubic function, right? The cubic function. That's the outside, outer, and the inner, it's this one, right? So this right here inside is the inner function, and then here you have the outer function. So if we compare this one, this is just by itself. This is just normal function. But if you notice, if we put it inside the power of negative 1/2, then this becomes the inner function, and this is the negative 1/2 power is the outer function. Here's another one. This quotient, if you notice that by itself is not a inner versus outer function, but if you put it inside the square root, now you have the inner function, it's inside the square root, right? The square root is the outside function. So think about it as this as the outer function. So one of the things that we need to be able to recognize is what is the outer function and what is the inner function when you look at the function, right? So those are things that I'm going to point out throughout these examples, so for you guys to keep in mind that that's something you have to check, you have to find, you have to be able to feel comfortable. So by practice, you'll be able to pick this up much faster, right? So in the first example, we're going to try to do finding a derivative of a composite function without the use of chain rule, right? So what would happen if we never knew about chain rule, right? And we had to find a different way to find the derivative. This means that we can find the derivative of function in different forms, right? In different ways. So, but knowing how to do the chain rule is much faster and much convenient for the most time. Sometimes that's the only way we can do it. Sometimes that's the only way we can do it. All right. So in this example, we'll just practice what's the inner function, what's the outside function. So the inner function is this right here, the polynomial, that this binomial, and the outer function is being a square function, right? So if you had like this is a outer function, right? That's a function, and that will be your outer function. So anyways, so let's pretend that we don't know chain rule, so we have to find the derivative of this. So because this is a power, this is a square, we know we can go ahead and already made a mistake here. That's a cubed. We can rewrite this as the product of two functions, right? The same function. So so then what we're gonna do here is we recognize that now this is a product of two functions. So we could come back and say, well, whenever we're doing product of two functions, we can use the product rule, right? So let's go ahead and do that now. F prime of x is going to be the first function, the derivative of the first function, times the second one left alone plus now the first function left alone times the derivative of the second function. All right, let's go ahead and find the derivative of this one, right? So the derivative of this will be 12x squared plus 15, right? Close the parentheses because this came from a derivative, so that's a quantity. This factor is just carried over this one as well because we don't have to do anything. This one, the next one, that we have to take the derivative, which happens to be 12x squared plus 15. And if you notice, these are the same terms, right? They're exactly the same. I mean, they have the factors in a different order, but they're the same thing. So if you pretend that this is W and this is W, you're pretty much adding W and W, so you get what? 2W, right? So what I'm trying to say here is that we could just add these together. And this will give us the derivative, right? So there you go. We found the derivative of this function, right? All right, so we're gonna explore what would be, what is the chain rule. So the chain rule, it's important for us to recognize that there is an inner function and there's an outer function. In this example, we're assuming the composition function happens to be where f is the outer and g is the inner function, right? So we can see it here as well. So we're taking the derivative of this. To find the derivative of this, what we need to do is, and you kind of see it here, you can almost see it here. So if I switch the order, right, let's say this is the order. If you compare from here, from the original function to here, it looks like what we did was we brought down the power down, the 2 there, right? And then we notice this part of the function, the inside function, is right there. It seems like we decreased 1 power, right? We went down 1 power, and then we multiply by this, which is the derivative of the inside. So what we did here is, it seems like we just brought down the power, multiply by the inside, subtract 1, and then multiply by the derivative of the inside, right? And that's exactly what the chain rule says. It says take the derivative of the outside, right? In our case, we use power rule. Leave the inside as it is, and then multiply the entire thing by the derivative of the inside. Here is a better way to see it using the general power rule. If you think about this one, you have the inner function is g, and the outer function is the power form, right? The power form, the power function. And when we take the derivative of this, we're basically doing the same thing that we had up here. We're gonna take the derivative of the outside. So instead of like ignore the inside for now, how do you take the derivative of a power, right? In the power form, you bring down the power, right there, multiply, leave the inside as it is, and then take away 1 from the power, right? If you had this like an x, right? It seems like just power rule, right? It just seems like power rule. Like if you had just a simple x, and I ask you find the derivative of x to the n, well, you will bring down the n, subtract 1. Exactly, that's what we're doing. Exactly, that's what we're doing. Except that instead of having just an x here, we have a whole function, and but we eventually you're gonna take care of that g at the end by just multiplying the whole thing by the derivative of the inside. And that's another way we can think about it is like this, right? You have u, right? You have u to the n, where u is the inside function. You take the derivative of the outside by using power rule, right? Bring down the power, subtract 1, leave the inside as it is, and then multiply by the derivative of the inside. So let's go ahead and try this example. Example 2. We're going to do the same thing right here. I'm going to rewrite the problem. And I'm going to go ahead and take the derivative. But I'm going to do it and I'm going to set it up for us, right? So we're going to take care of the derivative of the outside. Maybe I'll highlight the outside right here. The outside is this part right here, right? And then the inside is this one right here, right? That's your inside. So we're going to take the derivative of the yellow part, the outside. So ignore the inside for now. So if we take the derivative of the power form by using power rule, we bring down the power, leave the inside as it is, and then take away 1 from the power, right? And then multiply it by the derivative of the inside. That's exactly what we're doing, right? You've noticed that? Power rule of the outside, leave the inside as it is, and then multiply by the derivative of the inside. So let's bring down the inside. Right? And so you kind of set it up for yourself. All you gotta do now is take the derivative of the second of the last part, right? The derivative of this, right? Which is not so bad. It's just gonna be 4 times 3x squared plus 15, right? The derivative of x cubed is 3x squared. And I'm just gonna go ahead and do one more step here. There you go. So the derivative of this function using chain rule is this, right? All right, so the chain rule is very important for the derivatives. It's one of the most important rules that we have. It actually opens the door to find more types of derivatives. We're going to use that often here. And so I hope you guys find this helpful, this little introduction. And we'll try a few more problems in the next video.